Good afternoon. Today we are going to continue talking about PERMDAS with CO11. I can simplify expressions by squaring and using square roots. So we're going to dissect that PERMDAS a little bit. We touched on it a little bit yesterday, and we're going to talk a little bit more about it today with the E and the R. Because we know the multiplying, dividing, adding, subtracting, the parentheses. So today we're going to focus on that ER, the exponents and the radicals. So we're going to complete the tables below to help us remember the perfect squares. So when we square a number, that's like if we say 3 squared, we had that in yesterday's assignment, it's the same as saying 3 times 3. So when you're squaring a number, you're multiplying it by itself. So perfect squares are honestly my favorite kind of numbers. So we're going to get to know those perfect squares. We're going to get to love those perfect squares. So we're going to fill out our table so we can see what our perfect squares are. So 1 squared is 1 times 1, so that's 1. 2 squared would be 2 times 2 is 4. 3 squared is 3 times 3, which is 9. 4 squared, 5 squared. You're going to see how well you know your multiplication tables to see if you know your perfect squares. And then I'm going to go back and I'm going to fill in what our answers are. I honestly, in my head, I can go up to 12 squared easily. These upper teens are a little bit harder for me. I have to stop and really think about those ones. But you should, if you could know up to 12, you're going to be sitting really good. So 4 squared, 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. 15 times 15 is 225. 16 times 16 is 256. These are called perfect squares because these numbers, take one number, you multiply it by itself, and you get that answer. You will see a lot of patterns happen in math based on perfect squares. So it's important that you get to know what these numbers are, what makes them special. You will see them all the time once you really start thinking, oh, that's a perfect square. It will definitely help us when we do our square roots, the radicals. The square root symbol looks like that. So up here we have our exponent is that little number up to the right of the base. The base is that main big number. So the base is the big number. The exponent is the little number up to the right. Your square root is this symbol, and that means that we're going to break down that square root. If it's a perfect square, it will break down to the number that you multiply by itself to get to it. So our square root of 1, 1 times 1 equals 1. So our square root is 1. Square root of 4 is what number multiplied by itself equals 4. So that is 2. And we have our square root of 9 is going to be 3. And you can see how we're going backwards from what we have on the table on top of us. So the square root of 16 is 4. The square root of 25 is 5. Square root of 36 is 6. And we're going to go, you can see that these numbers are just going on down in order, just like when we were squaring them. So our square root goes with what that perfect square is. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. So the square root of that 100 is 10. The square root of 121 is 11, because 11 times 11 is 121. Square root of 144 is 12. Square root of 169 is 13. Square root of 196 is 14. Square root of 225 is 15. And the square root of 256 is 16. So they work backwards, the perfect squares and our square roots. This is super important. Remember not to multiply the exponent by the base. 3 to the 3 squared, 3 to the second power is not 6. It is 3 times 3. So whatever your exponent is how many times you're multiplying that number by itself. So not on this worksheet, but it is good for you to know. If our number is 3 to the 4th, that is the same as saying 3 times 3 times 3 times 3, because we have a 4 as our exponent. We're multiplying that 3 4 times. So nowhere in here do we see the number 4. We're just multiplying that 3 out. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is, I believe off the top of my head, I think it's 81. So you're just multiplying that number repeatedly. You are not multiplying it by the 4. 3 to the 4th power is not 12. 81 is a much different number. So when you take the square root, don't just divide by 2. So the square root of 16 is not 8. Yes, 8 times 2 is 16, but remember that square root is the number multiplied by itself. So when you make either of these serious mathematical errors, you bring Mr. Schultz one day closer to retirement, and he is an amazing teacher. We don't want that to happen, so try not to make that mistake. I do want to show you how you can check this with your calculator. On the test, you are not able to use your calculator, but I want you to be able to check your work. So when we look at our calculator, we need to know what the buttons mean. So if we want to do that 3 squared, you're going to put 3, and then you're going to put this little, well, you can, if you're just squaring it, you can do the squared button, and that'll go exactly to 3 squared, which is 9, 3 times 3. But if we need to do 3 to the 4th power, we're going to do 3, and we can't do that button because that's only squaring it. So if we want to go to the 4th power, we're going to do this button that goes up to that right corner, and we see that little caret. That means it's the exponent. So 3 to the 4th power is 81. So the math I did in my head was right on. So in order to do 3 to a bigger number, you're going to do the little caret. And if you're going to just do the squared, you do the x squared. So 3 squared equals 9. To find the square root of a number, we would do the second button, and then where you see that square root symbol written on your calculator, so you're going to do the square root of 9 equals 3. So some of us that have a different style calculator, it might not be on the actual calculator like that. It might be a little bit differently, and I'll have to show you that separately one-on-one to show you how to find that square root. But on this style of calculator, if we want to do the square root, we do that, and then we could do the square root of 4 is 2. So that's how we can check our work. Again, on the test, you're going to need to know these perfect squares and their square roots. But in order to check our work to make sure we're doing it correctly, I wanted you to see how to do it on the calculator. So let's look back at our work. So we have our perfect squares and we have our square roots. I'm going to erase so I can scroll up. So use the tables above and the order of operations to evaluate the expressions. So here's what you're going to do. In this first row, you're just going to be squaring your numbers. That is in the tables. So if you filled in your tables, that should go pretty quick. And in the second part, you're finding the square root. Again, that's in our table. Now we're going to our order of operations. So we're going to look and say, okay, for PERMDAS, I know where my levels are. There's no parentheses. I go right to exponents and radicals. So reading from left to right, what I come to first. So 7 squared is 49. The square root of 16 is 4. Now I'm going to bring down my operation. So now I know it's 49 minus 4 gives me 45 for my answer. So let's look over. So this one, we see there's a 36 divided by 121 inside the square root. So we're going to do the square root of 36 and the square root of 121. So we can do the square root of 36 divided by the square root of 121. So the square root of 36 would be 6. The square root of 121 is 11. So that gives us our 6/11. So if it's inside the square root like that, you can do the fraction, you can do it to square root of 36 over the square root of 121. Let's look down at, let's do this last one together. We have parentheses and a square root sign. Remember your PERMDAS. Parentheses first, and then you do your radical. Okay? So just remember to take it one step at a time. Remember to bring down the operations as you do your steps. We have exponent, exponent, radical. Then make sure you're bringing down your operation to find, and then you have to look, oh, I'm going to do my multiplying first, and then I'm adding. Okay, so remember your order. I don't want to do it all for you because I want you to get the practice of doing it. But I want you to do each step at a time. Remember to bring down your operation and then do that next level. Bring down your numbers and operations that you haven't used yet. Do the next level until you get all the way down to the bottom. Actually, let's go through one to help us with that. So if we have 15 squared, let's do this one. 15 squared is 225. Then I have another exponent. 14 squared is 196. And 13 squared is 169. Then I'm going to bring down my operations. Now I have to go, okay, adding and subtracting come next because there's no multiplying or dividing in this problem. So I'm going to do 225 minus 196. So 225 minus 196 equals 29 plus 169. And I'm going to do that. And that gets me 198. That's my final answer because I have no more operations to do. So you do one step at a time. Do your parentheses, then you do your exponents and radicals. Bring down the operations you haven't used yet. Then you look for multiplying and dividing. Bring down any operations you haven't used yet. Then you do adding and subtracting. Using an exponent in one and a radical in the other, write two expressions that each equal the page number. So our page number is 23. You can see that right there. So we want to, using exponents, write an expression that equals 23, and using a radical, that square root, you want to equal 23. So just like yesterday when we came up with these expressions, they will vary on how we get to it. Just know that one of them you need to use an exponent, and the other one you need to use a radical. You can use whatever other operations you need to equal that 23. And like yesterday, I said that multiplying, dividing by 1, adding, subtracting 0, you only get to use that once in your expression. So with that, I'm going to say I hope you are doing well, and I hope to see you soon. Have a wonderful day.